In today's video, we're going to be learning how to create this particular particles to text transition using any text you want, and it could even be done using any SVG or curve that you want. I've made a similar video before, except we used actual particle simulations back then, and that is very heavy on your laptop and you don't have as many settings as if you do it by yourself using simulation nodes. So we're going to go step by step in Blender version 3.6 to learn how to create this absolutely customizable procedurally to your liking. So let's find out how we can do it. In our default scene, we're going to bring our cursor to the junction of these two windows, click and drag to create a new window, and we're going to change the type from the 3D viewport to the geometry node editor. Next, we'll press this plus button to create a new geometry node tree, and we're going to select the group input and press X to delete it. Now we want this entire effect to happen on text. Of course, you could use SVGs as well or curves, but I'm just going to use text. So the way you can import text in geometry nodes is by searching for a string node, and you can type in whatever text you want. However, every single string node can accept only a single line. So I want Dayan Academy to be present in 2 lines, so I'm going to have to do something special. For now, I'm going to use Dayan on 1 string node and then press Shift D to create a new string node, and I'm going to change this one to Academy, and then I'm going to join these two using a join strings node, and there's a delimiter socket present over here which essentially decides what is present or what character is present between these two strings that are being joined, or any number of strings. You could always add in some more, but to visualize it we can't directly plug this into the group output because strings do not have any geometry. So I'll go ahead and search for a string to curves node and just plug that in so that we can actually see what we're doing. So this particular delimiter socket, if I actually type in something here like and, you'll see you get Dayan and Academy. It's essentially what's joining these two together. So instead of using something in the socket, I'm going to actually plug in a special character which is going to be a line break to get it to go to the next line. So I'll search for special characters and just use this line break into the delimiter. Now we have Dayan Academy. Next, I want to actually play around with the font and everything. So I'll go ahead and press this button and select the font that I want from my Windows font folder. I'm going to use Bank Gothic for this particular animation, and I'm going to change the alignment from left to center, and the same thing vertically. I'm just going to change it to middle. Now, if you want some more customization, that is, if you don't want it to be on the horizontal plane, you can always search for a transform geometry node so that you can actually rotate it on maybe the x-axis by 90 degrees to make it vertical, and you can also lift it up on the z-axis. But I'm going to do this entire effect on the 2D plane itself, although the exact same thing works even if you transform it. So I'm actually going to leave the transform geometry in case somebody who uses this file later on wants to transform it, but I'll leave it at 0 and 0 for now. And then I actually want these curves to be made up of points instead of actual curves. So I'll press Shift A and search for a curve to points node and just plug that in. And I want the number of curves, or at least the size of these points, to be much smaller for helping us in visualizing it. So I'll search for a set point radius node and just change the radius down to maybe 0.02, and this is what it looks like. Now obviously there aren't enough points to actually visualize the entire letter, so I'm going to have to increase the count. Remember, this particular count in the curves to point node is for every single curve, so each letter can be made up of multiple curves as well. I'll just increase the count to show that. So if I increase it to maybe 200, you can see we have a really nice distribution of points, and the letter D is actually made up of 2 curves. So there's actually 200 curves, or 200 points in this inner D and 200 points in the outer D as well. Whereas for the E, it's made up of only 1 curve, so there's 200 points like this. Now, I think just to make sure that even longer letters like E, and if there's a W, they take up quite a lot of points, so I'm going to increase the count to 400 so that every single one of them looks absolutely smooth. Next, we need to know the total number of points that were created. Now, you could manually do that by counting the number of curves and multiplying them by the number of counts present in the curves to point node, but a way to do this procedurally is by pressing Shift A and searching for a realize instance node so that each point individually can be calculated in all future nodes, and then we can search for a domain size node and just plug the geometry in from the realize instances into the geometry of the domain size. Now remember, we've converted the curve to points, so that means everything that's coming out from here are all points. So I have to change this from mesh to point cloud, and then I have the point count over here which we can use for all future calculations. So with that, we can actually start off with creating the actual points that are going to be simulated and moved around to eventually form Dayan Academy. Those points can come from any shape or even a different logo curve that you have, but for simplicity in this particular video, I'm going to use 2 examples, one being a plain grid and the other being a mesh circle. So I'll press Shift A and search for a grid, and I need the number of points that come out from this grid to be equal to the number of points over here. The way I can do that is by actually playing around with the number of vertices on the X and the Y. Now remember, from elementary math, we know that if we have a grid which is perfectly square, which means the same number of vertices here and there, if you actually look at the number of points on each edge, the total number of points is going to be the square of the number of points on each line, which means if we have 3 on one axis, then the total number is going to be 3 squared, which is going to be equal to 9 points. Now that means if I want a total of 9 points to be present, each of the axes have to be the square root of 9. Now suppose I want 10 points, a minimum of 10 points, then I'd have to search for the nearest square, which is actually 16, then take the root and make 4 vertices on each of the axes. Hopefully that made sense to you, but essentially another way that we can do it is, suppose we have, let's say, 150 points. We can take the square root of 150 to come up to be some value. Let's assume it's x, and obviously x, since 150 is not a perfect square, x is going to be some decimal. Let's say maybe it's 12 point something. I can't really calculate right now, but let's assume it's 12.67. To ensure that our grid has at least 150 points, all we have to do is round this up and have 13 points on each of the axes, and we just need a grid of 13 into 13. Hopefully I explained that well enough, but now we have to figure out how we can do that with the given information that we have. Our point cloud gives us the number of points, so we have to first find the square root of that point. So we press Shift A and search for a math node, and we change this from add to square root, and now we can plug this in. Next, we need to make sure that the square root is changed to the nearest whole number that is greater than the original value. To do that, we can search for another math node and change the type from add to another function that's present under the rounding called ceil. This will always round it up to the next greatest integer. Now we can just plug the value in, and this ceiling value we'll use for both the vertices on the x and the vertices on the y. This way we have the exact number of points that are necessary to create this particular curve, plus a few extra points may be there if the number is not a perfect square. So we have to actually delete all of the points that are extra, but before that we have to convert this mesh into a point cloud as well. I'll press Shift A and search for a mesh to points node and plug that in after the grid, and then I have to actually delete geometry. So I'll press Shift A and search for a delete geometry node, and essentially I need to delete every single point that is more than this particular number present here. So we know that every single point has a unique index which starts from 0 and starts counting up. Hence, I'll have to just compare the points to their indices, and if the index of a point is greater than the number required, we delete it. So I press Shift A and search for an index node, and I'll press Shift A and search for a compare node. Now remember, indices start from 0, but the number over here is starting from 1. Essentially, if we have 10,000, the last index that we should want is 9999 and not 10,000. So I'm going to have to change this from greater than to greater than or equal to. Now, if this index is greater than or equal to this particular number, from here, then it gets deleted. So we put this in, and then we plug this output into the selection for the delete geometry. Now, if we plug this geometry into the output of the group output, or into the geometry of the group output, we should get a grid with the exact number of points necessary to form the Ion Academy. And you can see the extra vertices have been deleted. However, I think that the grid is far too small, so I can increase the size on the X and the Y to make it maybe 5, and later on I might even change the aspect ratio by changing it down on the Y as well, so that it fits better with the aspect ratio of my camera. For now, I'll just keep it at 5 and 5. Next, again, by default, these points are 0.05 units in radius, but just to help visualize these better, I'm going to set the radius to make them slightly smaller. So I'll plug in a set point radius node and change the radius to 0.02. Now we can actually start the simulation nodes section of the tutorial, which is going to have two things. The first being, we need to compare the position of every single one of these vertices with the position of the vertex that it should be, which is the position that we'd get from these points over here. After we compare them, we have to get them to start moving in that direction, and we need to hence calculate the velocity with which it's moving, and we have to make sure that that velocity remains and slowly is damped off so that there's overshoot and things like that. Beyond that, I want there to also be some noise present during the entire animation. So I can press Shift A and search for a simulation zone and just plug this points into the input geometry, and the output geometry can go into the geometry of the group output. Then I'll just increase my size of the zone and then go ahead and figure out how each of these points should be moving. So the first thing that I need to do is find out the current position of these particles and the position to which they should be going. So I'll press Shift A and search for a vector math node and change this from add to subtract. This way Let's suppose that there are a few particles from the grid present like this and some other particles from the letter that's present maybe over here. So the green particles are where these blue particles have to go. The blue particles are from the grid and the green particles are from the letters. Now essentially, if I subtract the position of this green particle from the position of this blue particle, I will get a vector that points from the blue to the green, which is exactly what we want. However, if we actually move it by that much in a single frame, it'll directly jump from here to there, which we don't want. We want it to slowly increment. So we're going to have to find this yellow vector and then scale the vector down so that it moves only a slight amount every single frame. So every frame we find the position of this, subtract it from the position of this to get this yellow vector, and then we scale it down. So now we can actually figure out how to do that. First, we need the position of these particular points. So we have to actually sample every single one of these to get their positions. So I'll press Shift A and search for a sample index node, and I'll plug this geometry into the geometry, and I want to sample the position. So remember, position is a vector. So I have to change this from float to vector, and then I can press Shift A and search for a position node, and I can plug the position into the value, but I want to find it for every single one of the indices. So I have to press Shift A and search for an index node, which will iterate through every single point present. Now, if I plug that into the index, this value is the position of every single point in the strings. Now I can plug that into the first socket of the subtract node. Next, for the second socket, I need the position for every single one of these points. Hence, all I have to do is press Shift A and search for a position node, because in geometry nodes, again, everything is evaluated from the output side towards the input side. And since I'm going to eventually connect this subtract socket into the right hand side, which is getting all of the data from the grid and these points over here, the position value over here is going to take the position of the grid of points that we created over here. Hence, we can just plug this into the subtract node instead of actually sampling the indices over here. Again, this position node is again going to use what's to its right, which is this sample index, which is going to get its geometry from the realize instance of the curves. Hence, this position is going to give us the position for the curves, and this position is eventually going to give us the position of the grid. Now that we have the vector, I need to scale the vector down. So I'll press Shift A and search for a vector math node, and I'll change this from add to scale, and I'll plug the vector in, and I'll change the scale down to maybe 0.1 so that it doesn't move too much. Next, I actually have to set the position, which is going to happen every single frame. So that's going to be a part of the simulation zone. I'll press Shift A and search for a set position node and plug that into the simulation zone, and then take this vector and plug that into the offset. Now, if I actually play the animation, we should get these points to very quickly go from the grid to the Ion Academy. If this is happening and there's no extra points present, that means we're off to a good start. The next thing that we have to do is add in some noise to the initial grid as well as to the text while it's coming in. So to add in some noise to the initial grid, after this set point radius, I can go ahead and add in some noise by searching for a set position node. And remember, the offset will allow us to move the individual points around. So I'll press Shift A and search for a noise texture, and I can plug this color into the offset. However, the noise texture is going to move everything by 0.5 units on the X, Y, and Z on average. So I have to subtract that out. So I press Shift A and search for a vector math node and change this from add to subtract, and I'll subtract away 0.5 on all of the axes. Now that I have that, I can go back to frame 0 to actually restart the animation, and now you can see on frame 1 we have just a random distribution of points and not a nice perfect grid, which looks much better. Now many people might be thinking why we didn't use a distribute points on faces node, because that also gives a nice random distribution just like this. The problem with that is that we don't have the exact number of points necessary. We never know what the right number of points is. We just have to play around with the density till we get the correct number of points. Hence, this method is just a bit better in my opinion. Now the next thing that we have to do is actually add in noise to the motion so that it doesn't look this robotic. For that, we can play around with these nodes over here, which is the actual vector in which the particle is moving. So right now it's moving directly to the position that it has to lead up to. Instead of letting it move directly, maybe we can add in some noise to this vector. So to do that, again, we'll just press Shift A and search for a vector math node, and we're going to keep it at add itself. Then we're going to add in some noise by pressing Shift A and searching for a noise texture. And of course, we have to subtract it by 0.5 on all of the axes. So I'll take the subtract node, press Shift D, and plug the color into the vector. And for the second vector, I'll make it 0.5 so that it's centered around 0. And now I can plug this vector right into the add. But if we do this, you'll notice that even at the end, the noise still persists. And we don't want that. We eventually want the noise to die down. So we can press Shift A and add another vector math node, or take this scale node and press Shift D and plug that in. And by using this scale node, we can actually scale the noise down to 0 when we reach the end of the animation. So maybe till frame 90 we can have all of the noise texture. So this value will be a value of 1, and we'll just tap I, and then by frame 120 we'll get the noise to go all the way down to 0, and then we'll press I. Then we can select this and we can see the nodes. So now if we actually go back to frame 0 and play the animation, you can see there is a lot of noise, and eventually the noise dies down and it forms the AI Academy. Now beyond that, I also don't want it to start moving this fast. So from frame 0, from the grid, it immediately goes into the perfect positions. And to fix that, I can actually search for another scale node or just duplicate this scale node, plug it in here, and this time I'm going to start off with a very low value on the scale, which means 0 at frame 0, which means the particles are not going to find any attractive force towards its final position. If we play the animation, they just remain in their original places itself, and maybe by frame 70 the scale can go up to 1. So back on frame 1, I'll hover over the scale of 0 and press I, and then on frame 70 I'll change the scale to 1 and then tap I. Now if I play the animation, you can see that it starts off slow and then it speeds up. If I want it to remain slow for a bit longer, I can go to maybe frame 30 and just change the scale to 0.1 instead of 0.3, and then press I, so that now it's going to start even slower and then slowly speed up and come to its final position. Now the next thing is I need to actually play around with velocity. Now getting velocity using simulation nodes is fairly simple. We've done that multiple times in previous videos, or at least the last 2 videos that we've done on simulation nodes. You can check out the link to the previous video right here, where we actually go in a lot of detail about vector math and things like that. Do check those videos out. They will help you quite a bit in understanding simulation nodes. And so to create the velocity, we have to find the initial position of the points, and then we have to find the final position of the points, and we have to subtract them. So to get the initial positions, we can press Shift A and search for a capture attribute node and just plug that in over here. Of course, we want the position, which is a vector, so I have to change this from float to vector, and then I'll press Shift A and search for a position node and just plug that in over here. Now this attribute is the initial position. Next I need to find the final position, which is just going to be a position node, and I have to subtract the final position minus the initial position. So I press Shift A and search for a vector math node and change it from add to subtract, and then I can plug the final position into the top socket and the initial position into the bottom socket, and now this output I can plug into the output of the simulation output node. Next I want to change this name from vector to velocity, so I'll go to node, scroll down, select this vector that has been created because we added that in, and change this from vector to velocity. Now we also have this velocity present as an input, and to actually use the velocity and make it continue moving in that direction, all I have to do is search for another set position node. I'll move this set position towards the side, press Shift D and bring that in here. Make sure that all of the other connections also remain and don't get disconnected, and then I'll use this velocity as the offset. Now if I play the animation, there should be a lot of overshoot and they should keep moving, and that looks great, but I obviously want this velocity to die out much sooner instead of causing this much of commotion in the center for a very long time. So to start getting the offset velocity to reduce, I can press Shift A and search for a vector math node and scale it down by a little bit. I'll change this from add to scale and just plug that in to the offset and change the scale down to maybe 0.8. Now if I go back to frame 0 and play the animation, there's not too much of an overshoot, and that seems fine. The next thing is the strength of the noise texture seems to be a little too much in this region. So I'll go back to frame 40, select the scale node, take this keyframe that was keyframed at 1 and just grab it back to 40, but make sure only that one is selected, and then press G and bring it back. So now when we play the animation, the noise should slowly start dying off a bit faster, which seems perfectly alright. And now we can actually change the end frame to 150, and while we're at it, we'll set all of the animation defaults. So I'll go to my render properties, switch on ambient occlusion, bloom, and screen space reflections. Then I'll go to my output properties, change the frame rate to 30 frames per second, change the end frame to 150, and the output can be wherever you want it to be. File format is going to be FFmpeg video. Encoding can be changed to MPEG-4, and an output quality of perceptually lossless. Now if we play the animation, this is what it looks like, and I think that's perfectly alright. So we can start off with converting these from points to actual geometry once it's rendered. To do that, we go to this group output, drag it to the side, and then press Shift A and search for an instance on points node. Now for the actual instance, we're going to use an icosphere. We're going to keep the subdivisions at 1, but we're going to reduce the radius down to the value of 0.02, which is what we use to visualize the points, and we can plug that into the instance. Now if you play the animation, you can see that we actually have real icospheres that are going in and forming the word AI Academy. If you want to play around with the materials according to the speed, you can do that based on the previous video uploaded that's linked in the top right corner over here. But for now, we're just going to use a single value by pressing Shift A and searching for a set material node and plugging that in. But but I also want to just shade it smooth. So I'll press Shift A and search for a set shade smooth node as well and plug that before the set material. For the material, I'll use the default material, and that's all there is for the geometry node section. Next, we'll create our actual materials, and since it's only one material, we don't even have to go to the shader editor. All we'll do is go to the material properties by pressing this button over here, and for the default material, I'm going to actually give it a slightly yellowish tint, or a golden tint is what it's supposed to be, and then I'm going to increase the metallicness all the way to 1 and reduce the roughness all the way to 0. Then to actually see the changes, I'm going to change my viewport display from solid to rendered, and I'll just switch off overlays for now. Now I feel like I need to increase the roughness quite a bit, so I'll just increase the roughness to 0.4, and that seems alright. I don't want the light, so I'll select it and press delete to remove it. In my world properties, I'm going to increase the color all the way to white, and then I need some background, so I'll press Shift A and search for a mesh plane and just scale it up, and it's going to be right on the words. I want it to be a little lower, so I'll press GZ and just bring it down, and then again press 7 to go to my top view, and that seems alright. Now I'll press Ctrl Alt 0 to snap my camera to the view. Then I'll select the camera, go to the object data properties over here, and just zero out the X and the Y so that it's perfectly centralized, and if there is any rotation, you can zero those out as well. Beyond that, I want there to actually be more ambient occlusion, so I'll go to my render properties, expand ambient occlusion, and increase the distance to something like 10, and increase the factor all the way to 5. Then I'll select the background plane and just press GY, GZ and bring it down a bit so that there's a little bit more of the ambient occlusion actually showing. Then if I go back to frame 0, I can see that there are particles present outside the camera view as well. I don't really want that, so I'll select them. Under the geometry node grid that we created over here, I'm going to go ahead and just reduce the size on the Y, but to actually see the changes reflect, you have to make sure that you're on frame 1 and just reduce the size down to 2.3 seems fine, and even on the X I just want to bring it in a little bit, so yeah, a value of 4 seems fine. Now if I play the animation, they start from there and they slowly form the different letters with quite a bit of noise that slowly dies down and forms the Dayan Academy. Now I might play around with the timings of this keyframe over here and the timings of the keyframe over here, but essentially that's all there is to this particular effect. Of course, you can animate the camera as well to maybe start off at an angle like this, and as the time goes, it could maybe go into the final position on top, but that's completely up to you and how you want to do it. And if you're happy with the camera animation, the materials and everything, all you have to do is go ahead and press render animation. I had mentioned that I would also show you how to do it from a circle instead of a grid. So it's a very simple thing. You don't have to worry too much. All you have to do is press Shift and search for a mesh circle. And for the vertices, you can go ahead and just directly use this point cloud count and then plug this mesh into the mesh to points. With that, if you actually go back to frame 0, you see you'll have a circle, and from that circle, you'll get all of these different animations. The radius of the circle can be whatever you want it to be. So if you have a much larger radius, it's going to start off from a much larger size. Of course, I don't want it to be 8, maybe we'll go with 5. And then if you play the animation, it starts from outside and then it comes inside to form the text. So that's actually all there is to it. You just have to make sure that whatever curve, mesh, or shape you're using starts off with that many vertices, and then you can get the exact same animations. With that, we'll just transition back into the original video. With that, you'll get something that looks like this, and I really hope you found this useful. Of course, the last few videos that I'm uploading has a lot of math getting involved, and that's just the nature of simulation nodes, but I think it's really handy to learn. So I find this one of the most amazing applications of vector math, and I really think that students should be using Blender to learn vector math even in school, because that gives them a lot more motivation than what's present at the moment. And hopefully one day we'll be seeing that happening. So until that day, I'm going to keep posting videos so that all of you can learn Blender and create amazing results. Until the next video comes out tomorrow, stay tuned and don't forget to stay creative.